Your controller says 100 degrees centigrade. Your mold also measures 100 degrees centigrade. Yet your parts still warp, shrink, and come out inconsistent. So what's actually wrong? The answer changes how you think about mold temperature control. A controller controls temperature. It doesn't guarantee uniform heat transfer. Your temperature control unit shows 100 degrees centigrade, but heat isn't moving evenly through the mold. The controller isn't the problem. Heat transfer is. Here are 5 biggest reasons why. Problem number 1 is uneven flow through cooling channels. Not every cooling channel receives the same amount of coolant. Some channels carry more flow, while others receive much less. As a result, one part of the mold cools faster than another. This creates uneven shrinkage inside the plastic part, and that's when defect like warpage begins to appear. The goal is not just cooling, the goal is uniform cooling everywhere. Problem number 2 is air trapped inside the cooling channels. Air is a very poor conductor of heat. If air gets trapped inside the channel, coolant can no longer remove heat effectively from that area. That section of mold stays hotter than the rest. These hotspots lead to uneven cooling and often causes shrinkage or sink marks on the molded part. Simply removing trapped air can significantly improve cooling performance. Problem number 3 is scale buildup inside the cooling channels. Minerals present in the water slowly deposits on the channel wall. Over time, this forms a hard insulating layer. Even though coolant is still flowing, heat cannot pass efficiently through the scale. Heat transfer drops, cooling cycle becomes slower, and the cycle time increases. Regular cleaning and proper water treatment help prevent this problem. Problem number 4 is a blocked cooling circuit. Debris, rust, scale, or internal damage can completely block the flow inside a channel. Once the flow stops, that section of mold receives almost no cooling. The temperature rises quickly, creating hotspots. This can lead to dimensional defects, shrinkage, warpage, and inconsistent product quality. Good filtration and periodic flushing are essential to keep channels clear. Problem number 5 is poor cooling channel design. Sometimes the cooling channels are placed too far away from the mold cavity. Heat then has to travel a much longer distance before reaching the coolant. Some areas cool quickly while others remain hot. The result is uneven cooling, longer cycle times, and inconsistent part dimensions. Good cooling starts with good mold design, not just a powerful temperature controller. So even if your sensor is in correct location, PID is tuned perfectly, controller shows exact set points, you still have defective parts because heat transfer is not uniform. Why this happens? The temperature controller unit controls the fluid temperature, but not how heat moves through the mold channels. Most engineers adjust PID. Experienced engineers fix heat transfer because the controller can only control what the mold allows. Next time, we will talk about one parameter almost everyone ignores, but it affects cooling more than the temperature itself.